give them?
Yeah,
They want a rubric connected to the work package.
All right, ladies and gentlemen, now we're going to start class for everybody
Yo, you
who
missed
wants
two
to
already.
know how this applies.
Man here,
We
man.
are taking technology math. Technology math is an off branch of Mr. Sears' class. Yesterday you learned about exponents in his class. So today we're going to take that to the next level and we're going to discuss number-based systems, binary, hexadecimal, and octadecimal numbers. So, as you see, we have some of the lesson plan that's listed here, some of our common core standards. I know you guys are happy about that. But at the end of the day, we want to know how this is going to apply to the lesson, how this is going to apply to the real world. For all you gamers and hardcore computer experts, if you don't understand binary and understand hexadecimal or octadecimal, then you're definitely behind on what you consider to be your perfect skill. So if you want to be a gamer, a programmer, an app designer, this is something you need to pay attention to.
Yeah, it's just this old shit they used to let you do when you had the Commodore 64.
Right.
You were trying to
Right.
enter the game. You
Right.
had to type the program.
So what we're going to discuss, since it was some of yesterday's lesson, Mr. Sears discussed exponents. So we're going to go over to our binary data sheet, and we're going to start plugging in some numbers. One thing that you have to remember that Mr. Sears told you yesterday is that anything to the 0 power is 1. Please remember that. If not, you would definitely throw your numbers off. This is an 8-bit sequence. So remember, Nintendo 64, Nintendo, Atari, those were 8-bit game systems for those guys who want to know. So we're going to fill this out. But what we're going to touch base on before we go here, who remembers the two multiplication tables? So just give me an example of 2 times something.
3 times 5 is 35.
35, okay. So what we want to get is the understanding of doubling. Everything is about doubling, multiplying with binary. So we have 1 or 1. The next number over, 2 to the first power will be what if we're doubling?
2.
That's right.
You know what's so bizarre?
What's next? 2 to the 2 is
Right to
4.
left.
4.
I know, it called to whatever.
That's supposed to be that way?
Yes.
That's crazy.
Yeah, I'll explain that
All right,
shortly.
I'm sorry.
So, 4. What will be after 4 if we're doubling?
8.
8.
Crazy.
What will be after 8 if we're doubling?
16.
After 16?
32.
32.
64.
64.
128.
128 bits. Has anybody ever heard of that?
Atari 128.
There we go. Now that's where that came from. 128 bits.
Old school.
Now you have an 8-bit game system where you put your cartridge in, but it reads 128 bits. So you have to include your gaming controls, which put into 4. So this here is your gaming controls. This portion here is the actual system itself, 128 bits. So that's how we're going to connect that to the real world. So, as Mr. P stated, he wanted to know why does it go from right to left. Now, we have a 4-bit, we have an 8-bit, we have a 16-bit, 32, just as much as we have there. So let's just say we want to come up with the number 33. Does anybody know how we will go about that? If we want to make the number 33 decimal.
2520. 2520.
Which one of these numbers here will we apply a 1 to?
For 30?
For 33.
33. 25 is on 30. 25
Uh-huh.
and 2
Now the rest of this will get filled in with zeros. Why? Because there's no place value. So how does that connect to decimal numbers? Who knows the number 10? Can anybody explain why we have the number 10 if it's only 0 through 9? Because we put a 1 in the tens place to signify that we went over to the tens. Leave that as a 0. It's the same concept with binary.
It starts over.
And it starts over. So now what we're going to do is we're going to go a little fast paced. We're going to move forward. And what we're going to do is start to convert some of these numbers. 173, 102, just as we did up right in there. And how we do that, we just start applying the ones to where the value goes. Ones and zeros, ones and zeros. As we see here. So if we was to take this and apply it up into our data sheet, we would get 128 plus 8 is 132, 136. This number here, the last one, is 136. 128 plus 8, 136. So what we would use for some of the students who can't grasp the 8-bit, we'll condense it down to a 4-bit, which is very similar to up there. Now, what we're going to do is learn how to code and make secret messages using binary. So any of you guys want to be a spy, want 007 stuff, this is where they get it. So when you start plugging into your keyboard, this is how you will make a G, this is how you make a K, and all the other letters. So the end result is we're going to fill this up into a 16-bit, and we're going to make a secret message, and that's going to be your exit slip in class. So if anybody has any questions, please ask me. I'm available on Blackboard via email. What I forgot to hand you was your homework sheet, so everybody please have one.
Oh, man. Homework. I already got homework.
Thank you, sir. Yo, you're gonna get 6 in the ass.
Oh.
You're gonna get that in class, you're not supposed to work, and he's fucking cute. He's fucking sexy.
Listen, I had that at
I'm
Chiefs.
fucking bullying.
I had that at Chiefs.
Yo, stop.
I had like panic, man. I was like, what do I do? Do I report?
Yo, stop, I'm teaching.